Okay, cool. So just to make sure we're all in the same wavelength. What's up? Oh, you found one?
Yeah.
I can get one back. All right. What is the square root of 16?
4.
Why is it 4? 4 times 4, I love it. So the square root asks you, what does it take 2 of to multiply to be this thing inside? So that's the trick with math, is to realize, I just don't want to write the freaking sentence out. I don't want to write, what does it take 2 of to multiply? No, so we have a symbol that means that question. So whenever you hit a new symbol in math, you have to internalize what the question is that it asks you. Has anybody ever heard of logarithms? Some of you guys? Same thing with logs. Logs are like, oh God, logs, it's so horrible and it's a word. What the hell shit? And you just internalize what the question is and it's easy. So we'll get there eventually. So this is definitely 4 because it takes 2 4s to make 16, 11. Kick ass. So just to push it a little bit, what do you think the cube root of 27 is?
3.
Yeah, because it takes 3 3s to multiply to be 27. Why do you think somebody would put 9 here? Yeah, exactly. But why would I make a whole new symbol for something we already have a symbol for, right? This is not divided by 3. This is the cube root of 27. So it's got to mean something different. You know, so that's 3. I like it. So what if I ask you, what's the square root of, what you got, Jeff? I don't know, man. 625.
25.
Yeah, look at somebody knowing it. I love it. But you know it's got to be something that ends in 5. But just so we can all catch up, how would you start to do this? How would you start to attack this problem? I mean, considering that this asks for what does it take 2 of, well, I can start to just factor it out to see what it takes 2 of to multiply it. So I can start the same thing here. So what definitely goes into 625? 5. And you can divide and you'll eventually get to the point where it's 125. Keep going. What goes into 125? 5. And you'll get 25. And then 25 is 5 times 5. I like it. So what is there 2 of? There's 2 5 times 5s. So there's 2 25s. That's why the answer is 25, because it takes 2 25s to multiply to be that. So even if I give you something disgusting or something you're not sure about, you just start breaking that bad boy up and see what it's made of. Does that make sense? Does that make sense? It's okay to say no? I'd rather say no now than on the test. All right. I like it. So what we're going to talk about now is, what do you do when the number's not evenly cut upable? Just to make up a word. Something like, what if I had the square root of 50? Well, let's all catch up. So, I think when I showed you this, it's been a little while, but when I showed you this last time, I showed you that thing about what's 10 divided by 3. Well, 3 doesn't go into 10. But 3 goes into a part of 10. 3 goes into 9. Stay with me now. Right? So I can break this up as something that 3 goes into plus the rest. I think that's exactly the example I gave. Do you see this? No. All right. What's not to see? So 10 is 9 plus 1. Now, why would I do that? Well, I wouldn't break it up as 8 plus 2, because does 3 go into 8 or 2? No. So I'm going to break it up into the biggest thing that 3 goes into, that's a part of 10, plus the rest. Now, I'm not asking you, would you do that? I'm asking you, do you see where I got that from and why? Okay. In fact, you normally wouldn't do this, but it's kind of cool to see it done this way, because the next step is, what's being divided by 3? What's being divided by 3? 9 and 1. So I can write 9 divided by 3 and 1 divided by 3. That is 3 and a third. 3 and a third. Now, I am not. I love it when students are like, I saw a better way to... No, this is a new, different way to think about making improper fractions become mixed numbers, right? You can see that there's one extra up there. Stupid one extra. If only it was 9, it'd be easy, right? Well, look here. Division is based on, what's multiplication really based on? Addition. So that's why I kind of broke this up as addition. What are roots based on? Multiplication. So what could I take the square root of that's a part of 50, that's a factor of 50? What's a factor of 50 that I could take the square root of? 25. All right, good. So a really good step, if you're having any trouble, you should know your squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 8, blah, blah, blah. You should make that list for you. You need to know those immediately, right? Up to 12 at least, if not beyond. So just like I did here, this is kind of cool. I can write this as square root of 25 times the square root of what? To make 50. 2. I like it. Square root of 25 is 5. What's the square root of 2? I don't freaking know. So it stays. Just like what's 9 divided by 3? 3. What's 1 divided by 3? Gross. So I leave it alone. Do you guys see that? It's very similar. It's remarkably similar. One is based on addition. The other one's based on multiplication. Okay, cool. I like it. I like it. Some of you guys see it. Some of you guys are almost paying attention. That's good. Almost is better than not. All right, let's do a couple more real quick here. So what about the square root of what, Jeff? I don't know, man. 63. So how could you break that up? It's a smart way to break that up. I could do 3 times 21, right? Yay, 3 times 21. Why is that silly? Why would I want to do 3 and 21? Because neither one of them are squares. I can't square root either one of those numbers. 9 and 7. Kick ass. Why is that a better way to do it? Because 9 is square rootable. Just to make up an adjective, right? So this would be square root of 9 times the square root of 7. Square root of 9 is 3. Square root of 7 is, I don't freaking know. Third base. Abbott Costello. No. Alright, maybe. So this is sort of similar to mixed numbers. This is a mixed number. This is a whole number and a radical number. So it's sort of like a mixed number. That's why the method is sort of the same. All right, let's do one more, and then I'll unleash you on that. So I'll show you a different method here. I'll show you the second method. I prefer the first method because there's no guessing. I'll show you the second method, though. You will, Jeff? Sure, I will. Okay. This would be kind of a funky one. So let me do it. Let me do this. You would never think of this, but well, screw it. This is like, what can go into 98? 2.
49.
And 49 is? So you could always break the number all the way down. What is square roots looking for? What are they looking for? Why can I do the square root of 9? Because 9 has what in it? 3 times 3 has 2 3s. So square root's looking for groups of 2. What do I see group of 2?
2 sevens.
So a 7 can come out. And the 2, poor little 2 is by itself, too bad for it. Right? So both of those methods are on that little worksheet. Method 1 I put, what did I put method 1? Thank God. Method 1 is the one I sort of say is better in a way, but if you did method 2, I'm not going to give you less points. Method 2 is valid. It's just that people give me the answer and they give me this as the answer. Which doesn't make any damn sense. There's only 1 2. How did it escape? Right? But people kind of guess where to put stuff. Here, there's no guessing. Square root of 9 is 3. There's no guessing there. Okay, so I know a few of you have already done some of this worksheet, but what I want you to do now is just kind of group up people near you and maybe fill in some holes. People didn't understand something. Finish that worksheet out, and then we'll do it together. Everybody has that worksheet right? All right. Sorry, I know it's early. You have to interact with other humans. You're surrounded by them right now. They're the deadliest animals, so be careful.